Hi, welcome to this video. In today's video, I'm going to give a general definition of concavity and convexity, okay? Consider y equal to f of x, which is assumed to be continuous function on an enclosed interval, AB. It exists 2 points, x1 and x2, such as x1 different than x2. F is called convex upward or convex downward if it holds the following conditions. Before to determine these conditions, I'm going to take a look at both graphs to see what's the convex upward and convex downward look like, okay? First of all, I'm going to take a look at the first graph, okay? So I have chosen 3 points on this interval, x1, x0, and x2, okay? Now I'm going to calculate the average of these 2 points, okay? Which is x1 and x2. So f of x0 equal to f of x1 plus x2 over 2. So by doing the average of these 2 points, okay, x0 equal to x1 plus x2 over 2, which is representing the average of these 2 points, I'm going to do the output of this average, which is 0. So f of x0 is represent output of these points equal to this one. I'm going to leave this empty space, okay? I will write f of x1 plus f of x2 over 2. So if you take a look at here, I have 3 inputs. I'm going to calculate the output of these points, which is f of x0, f of x0 by doing the extension, f of x1, f of x2. Then I'm going to do the average of these 2 outputs, f of x2 and f of x1. So the average of these 2 outputs, f of x2 and f of x1, is this one, which is f of x1 plus f of x2 over 2. In the middle, this is the average, it is located in the middle of these 2 points. Let's call it m, equal to m. Then I'm going to compare these 2 terms. Which one is smaller, which one is bigger, okay? If you take a look at the graph on vertical axis, you will see f of x0 is below m, okay, as a point. So that's mean this f of 0 is inferior or equal to this one, okay? This is the first case, okay? This one is called convex downward or convex. It has 2 names, okay? It's called convex downward, or convex okay? I'm going to see the second case. If you take a look at the second graph, I will have the same thing, an interval of x1, x0, and x2 points as a point. I'm going to do the output of these 3 points. I have f of x1, which is 1, by doing the extension. F of x0, which is located at the top of this function, is a maximum value. You can take f of x0, okay? And f of x2 is below it, okay? And down there, I have f of x1, okay? So f of x1 is strictly inferior than f of x2 and strictly inferior than f of x0, okay? As you see it on the vertical axis, okay? Now, I'm going to calculate the average of these 2 points. So this is second case. F of x0, okay, equal to f of x1 plus x2 over 2. This is the average of these 2 points, x1 plus x2 over 2 equal to x0, okay? Then I'm going to calculate the output of this average, which is f of x0, as you see it here by doing the extension, okay? As I wrote it here, okay? I'm going to leave this empty space between these 2 terms. So I will have f of x1 plus f of x2, okay, over 2. what this written is representing, okay? Is representing an average of these two outputs, which are f of x2 and f of x1, okay? So in the middle of this point, okay, is called n, because it's representing an average. An average of these 2 points, we have to put it in the middle as a midpoint, okay? So this one, let's put it equal to n. Now I'm going to compare these 2 terms. Which one is smaller, which one is bigger? Okay? If you take a look at here, I'm going to compare f of x0, which is this one, and this average, which is n. Okay? I see it is f of x0 is located above of this point n, which is strictly inferior or equal. Sometimes it could be equal. Depends. That's why I'm putting inferior or equal or superior or equal. Okay? So this one, as you see it here, f of x0 is superior or equal f of n. Okay? Now, I have completed 2 cases. Okay? Now, what's the name of this one? Now is called convex upward or concave. Okay? Since we have convex function, f of x1 plus x2 over 2 superior or equal f of x1 plus f of x2 over 2, okay? So f prime is continuous function on closed interval EB. The second derivative function is derivative function on open interval, okay? So the condition, if we have second derivative function f of x superior or equal to 0, okay? What does it mean? That means we have convex function, as you see it here, okay? Example, okay? Let's take in f of x equal to x squared, okay? So this is defined on ordinary numbers, so x, okay? So I'm going to calculate f of prime of x equal 2 times x, okay? This is derivative function all ordinary numbers, okay? So I'm going to calculate second derivative function of this one. Second derivative function of this one equal to 2. 2 is strictly superior than 0. So this one, f of x, f is convex function. So let's take the second example, okay? Concave function. Concave function, okay? So in the second case, we have concave function. Is verify this condition, f of x1 plus x2 over 2 inferior or equal f of x1 plus f of x2 over 2, okay? That's all we have before. Now, I'm going to see the first derivative function of this one. F prime is monotonically decreasing on closed interval EB. The second derivative function has to be negative, inferior or equal to 0, okay? Example for concave function, okay? Let's take f of x equal to natural log of x, okay? I'm going to take f of x equal to natural log of x as an example, okay? For ordinary number x strictly superior than 0, okay? So f of prime of x, so the function is accepting derivative function on this interval, in this open interval. So f of x equal to 1 over x. So whatever the number is, this function f prime is become smaller than smaller as the numbers going up. Okay, so as the numbers going up, okay, this function becomes smaller and smaller. Okay, that means it's decreasing over interval. Okay, so f prime, not f of x, f prime x is decreasing function, on 0 plus infinity. Okay, and then if I'm going to calculate f prime of x, I'm going to calculate now the second derivative of this function of x is given as 1 over x squared. If you take a look at here, this is strictly inferior than 0. Okay, that's what I'm looking for. What does it mean? That means verify this condition. F prime is monotonically decreasing. We found it. Okay, f prime is decreasing function, and then we have second derivative is inferior than 0, is negative. The important thing has to be negative. We found it. Second derivative of this function equal minus 1 over x squared, which is strictly inferior than 0. That's mean f is concave function. Okay. Okay, I have done with this lesson. Thank you for watching. I will see you in next video. Bye.